Welcome to the lecture. Today we are going to see the topic super mesh analysis. When we apply super mesh analysis, when the current source is common between two loops, then we will apply the super mesh analysis. To understand the concept of super mesh analysis, now we will see one example. Now find the current through 10 ohm resistor for the given network. So here this is the example. From this example, first we have to identify number of loops. In this example, we are having three loops. First, we have to assume the current in each loop. Let I1 be the current in loop 1, I2 be the current in loop 2, I3 be the current in loop 3. Now, you have to check whether the current source is present in the loop 1. No. So, here you are having a only voltage source. So that we can apply the normal KVL. So that apply KVL to loop 1. Apply KVL to loop 1. So, we have to check the given voltage source is voltage rise or voltage drop. So, given voltage source and the assumed current directions are in same direction. So, that the 2 volt source is a voltage rise. So, that we can write 2 equal to 1 into I1 plus 10 into I1 minus I2. By simplifying this equation, we will get 11 I1 minus 10 I2. So, rewrite this equation 11 I1 minus 10 I2 equal to 2. Take this as equation number 1. Similarly, for loop 2 and loop 3, we have to apply the KVL. So, before going to apply the KVL, you have to check the conditions. Here, the 4 amp current source is present in common between loop 2 and loop 3. So, here we have to apply the super mesh analysis instead of normal mesh analysis. So that by writing the equation for super mesh for loop 2 and loop 3, you have to remove the current 4 amps current source. So, loop 2 and loop 3 form super mesh. So, by writing the super mesh equation to remove the 4 amps current source. Now, so this 4 amp current source is present in common between loop 2 and loop 3. So that we are writing I2 minus I3 equal to minus 4 amps. Why we are writing minus 4 amps means here the assumed current direction of I2 is opposite to your given current source. So that we can write I2 minus I3 is equal to minus 4. So take this as equation number 2. Now, by writing the super mesh equation, here we are going to eliminate the 4 amps current source. So, the reduced circuit can be like this. Modified circuit is given by one ohm current resistance connected in series with the 2 volt. We will not disturb the loop 1. 10 ohm. Here we are going to apply the super mesh for loop 2 and loop 3. So this is I2 current, this is I3 current. So for this loop, now we have to write the KVL. Apply KVL to super mesh. Now, so in this loop, there is no voltage source, so that we are writing the equation 0 equal to 10 into I2 minus I1 plus 5 I2 plus 15 I3. Now, the current through 5 ohm resistor is I2, so that we are writing 5 I2. And the current through 15 ohm resistor is I3, so that we are writing 15 I3. So after simplifying this equation, here we can write minus 10 I1 plus 15 I2 plus 15 I3. So that we can rewrite this equation as minus 10 I1 plus 15 I2 plus 15 I3 equal to 0. Take this as equation number 3. Now solve equation 1, 2 and 3. We will get the current values. I1 equal to minus 2.35 amps, I2 equal to minus 2.78 amps, I3 equal to 1.22 amps. So this current may be determined either by using Cramer's rule, or we can solve by using calculator. Now, still the problem is not completed. So in your problem, what they are asking, find the current through 10 ohm resistor. Where the 10 ohm resistor is present, the 10 ohm resistor is presented in common between the loop 1 and loop 2. So the current through 10 ohm resistor is I1 minus I2. So that we can determine the current through 10 ohm resistor. So the last step is current through 10 ohm resistor is given by I 10 ohm is equal to I1 minus I2. That is I1 is minus 2.35 minus I2 is minus 2.78. If you simplify this equation, the current through 10 ohm resistor is 0.43 amps. That's all about Supernes analysis. Thank you.